So you drove by a wind farm and the turbines aren't spinning. What's going on there?
You and I have an insatiable appetite for electricity. Come with me and we'll look at the issues relative to wind farms and the communities that they serve. This is the Windfarm Guy.
Hi, this is Dennis Stout and thank you for joining me for this episode of the Windfarm Guy. Seeing some wind turbines in a wind farm not spinning while others are operating is common and can occur for several reasons. Wind turbines are complex machines and their operation depends on environmental, technical, operational, and economic factors. It might be insufficient or excessive wind speed. Turbines require a minimum wind speed, typically around 3 to 4 meters per second, which is about 6 to 9 miles per hour, to start spinning and generate electricity. If the wind is too weak, the turbine remains idle. They also have a maximum wind speed limit. Depending on the machine, it could be around 25 to 30 meters per second, or 55 to 67 miles an hour. During high winds or storms, turbines automatically shut down to prevent damage to blades, gearboxes, and other components. They may also be feathered, meaning the blades are turned parallel to the wind to stop rotation. Wind speed can vary across a wind farm due to terrain, turbulence, or wake effects from other turbines. Some turbines may not spin if they're in a low wind pocket while others operate. Maintenance or repairs accounts for some idle turbines. Turbines are periodically taken offline for preventive maintenance, such as lubricating components, inspecting blades, or replacing parts like bearings. You'll know this is happening if there's a pickup sitting at the bottom of one of the turbines. This is often done during low wind periods to minimize lost production. A turbine may stop due to a fault, such as a gearbox failure, electrical issue, or blade damage. Repairs can take hours to weeks, depending on the issue and availability of parts or cranes. In some cases, it could take months for the problem to be resolved. Drones or technicians may inspect blades or towers, requiring the turbine to be stopped for safety. There may be grid or operational constraints. Grid operators may instruct the wind farm to reduce or stop output to balance electricity supply and demand. This is called curtailment. For example, if the grid has excess power and not enough demand, turbines may be deliberately stopped. If the grid or substation is undergoing maintenance, turbines may be offline to prevent feeding electricity into an unstable or disconnected system. Environmental and regulatory restrictions. Turbines may be stopped during specific times to protect birds or bats, especially during migration seasons. For example, some wind farms halt operation at night or during low wind speeds to reduce bat collisions. In areas with strict sound regulations, turbines near homes may be paused at night or during certain conditions to comply with local laws. Turbines may be stopped during specific times of day to avoid shadow flicker from the moving blades disturbing nearby residents. Technical or safety issues. Modern turbines have sensors monitoring everything: vibrations, temperatures, and other parameters. If an anomaly is detected, like overheating or excessive vibration, the turbine automatically shuts down to prevent damage and workers are notified. In cold climates, ice buildup on blades can cause imbalance or safety hazards, leading to shutdown. Similarly, extreme heat or lightning risks may prompt turbines to stop. Glitches in the turbine's control system and communication with the Wind Farm Supervisory Control and Data Acquisition System, or SCADA for short, can cause a turbine to pause while it's resolved. Testing or commissioning. If the wind farm is new, under construction, or undergoing upgrades, some turbines may be offline for testing, calibration, or commissioning, and other reasons. This includes checking electrical connections, software updates, or retrofitted components like new blades. Economic and strategic decisions. In some energy markets, operators may choose to stop turbines when electricity prices are too low to cover operational costs, especially for older turbines with higher maintenance expenses. Or if a turbine is nearing the end of its design life and repair costs outweigh revenue, it may be taken offline pending decommissioning or repowering. If you like what I've said today, be sure and click like and subscribe below. If you have thoughts or want me to address a particular topic relative to wind farms, please also leave me a comment. A passerby has no idea the output level of say a nuclear, coal, or gas-fired power plant. However, it is painfully obvious for a wind farm. Everyone in the county can tell that it's not fully operating. You can't take that at face value. There are many good reasons for turbines not spinning. This is Dennis Stout, and I'm the Windfarm Guy.
Thank you for watching. Working together, we can make good energy decisions and save our planet. I am the Windfarm Guy.